What's going on, everybody? Feder here from 3D Print SOS. Welcome back to the channel. Today we are going to start working on our ultimate Aquila build, and it already has a couple things done to it, but we're going to continue making it better and better. And today we were supposed to go ahead and get an enclosure printed to start our electronics, but here's what happened. Well, I did get it printed, but it definitely printed with its fair share of issues. One is it had some really poor small hole performance, along with some kind of texture that's on the inside of all the walls on this print, including some on the outside, but not nearly as many as on the inside. So I decided to ditch this filament and get myself some quality Yusu silk gold, which printed really nicely on the outside. There's actually two problems here. One, I printed this on the Magician X, and I have some issues with it sticking a little bit too well, and actually broke quite a bit of it just trying to get it off the print bed. But then the problem still exists on the inside walls, so I figured I'd print it again. And this time it came out once again better, but the settings weren't enough. There's still something up with the inside walls. So I changed to a different machine and printed it again. Well, I noticed that the same thing started happening, and I canceled this one early because this is somewhat a long print. I didn't want to just keep wasting filament. But even though I changed machines, I still had the same issue. So I have a feeling that I have a funky size in my design on the inside of the wall here. That's why it's only having problems there and nowhere else really. Not even on some of the other sections that are on the inside wall that are a different size. But then this got me thinking, I wouldn't be able to install this anyway because this goes onto the front of the machine, and the whole part of my design is this. This is a 500mm extrusion that's supposed to be a brace between the left and the right side and the y-axis. And this enclosure is supposed to install right onto the front of it where I can mount it. But in order for us to do that, I need to undo a whole bunch of parts here. We need to drill through this. We need to tap into the extrusions on the machine on the front end there. We need to use this piece that I designed that slides into the bottom of the Y extrusion and then gets mounted onto the front of this brace, essentially giving us a place to be able to install all the electronics. So that gives me some time to figure out what this is, what the problem I'm running into here is. And also I noticed that I think I need to have some more room here. This side is going to have a Raspberry Pi, so there's going to be a ton of wiring here, and I think I want some more breathing room in here. So back to the drawing board with this, unfortunately, but we're still going to get a bunch done. One of the other things that I want to do is I have these riser feet that attach to this chassis brace. Essentially, they slide in like this. They go into the tapped holes on the front of the chassis, and they're going to make this thing sit up a little bit higher and just clean it up. And I have a set for the back as well. So while I'm drilling and tapping, I'll go ahead and make sure that the feet are on and working. So that's a really important step. In addition to that, I also took a poll in the community section and asked you guys what modification you wanted to see, whether it's a hot end, etc., etc. There was a long list of things, and you guys, by a long shot, voted this, a Dual Z Kit. This one is from Creality, and I got it from Ender Extender. I'll have links down below where you guys can grab a kit as well. And this has everything that you need to get a Dual Z setup complete on an Ender or Aquila, down to the wiring and the motor and everything else that you might need, like the hardware, etc., etc. So this is going to be a really nice kit. So one thing to note is this is an extended Aquila width-wise, but it is not extended in the Z-axis. So the installation of this Dual Z should be the same as a stock Ender or a stock Aquila. So you guys can follow along if that's something that you're interested in doing, or at least are interested to see how hard or how easy it is to install this kit. So I'll be sure to show that off. So just to recap, we are going to be working on the chassis brace and mounting system that I developed for the front of this extended Aquila, and we're also going to do a Dual Z kit on this machine to get this project moving along. And I have a lot of fun stuff coming up for this thing, so definitely going to be a long-term project on the channel. All right, without further ado, let's get all this cleaned up, let's start taking this apart, and let's get ready to do some drilling and some tapping. All right, see you down there. All right, so there it is. We got the front all braced. Just 3 pieces that are printed and then a little bit of hardware. We had to drill some holes through the extrusion that were big enough for our M5 bolts. And luckily the front of the chassis, the 40 by 40s here that are already on the printer, they have already been tapped. So this front end chassis brace was actually really easy to do. Then here is the back. All right, the back, we did have to use taps, and I gotta say these taps and drill bits that I got are so much better than what I had before. So if you guys definitely need some taps, I'll have some links down in the description. These are solid. I feel like these things didn't even struggle whatsoever. Super easy to tap these aluminum extrusions with these. Like I mentioned, my previous set was so much worse. I struggled all the time tapping this type of stuff. So yeah, we had to drill just 2 corners on each side. We don't need any more anything else because it actually rests on the plastic anyway. So we just tap these just to hold these on, and the feet are nice and sturdy. Now I did notice that there was a slight wobble in the feet, and what it was is you can actually undo the 4 bolts holding these the middle chassis together. Just loosen them all up and kind of bang on it on an even surface on the one you're holding the printer on, then tighten them back up, and bam, this thing is nice and sturdy and it's lifted off the ground. It's much easier to maneuver. Obviously I still have wires everywhere because we don't have anything hooked up, but it is definitely much nicer. I love the way it looks. And if I move this bed back, which by the way, this feels nice and sturdy, you know, now we have a nice solid foundation for this giant bed to be slinging back and forth. But if you look here, here's all of the wiring. Let me turn it a little bit more. There's all the wiring is right here, ready for us to make some kind of enclosure. So I will definitely get on that at some point after we do the Z. So now that this is complete, let's keep moving along. Next thing we're gonna do, dual Z axis. Let's get to it. All right guys, just wanted to point something out with this kit. In the wiring here, let me undo it, the little bundle of wires that you get with the Creality kit, there is a little sheath you can use for the wiring, but then there's this wire. It is not only an extension, but it's also a splitter. So it has 2 connectors for your Z, so that on a Creality board that only has 1 Z plug at the end here where you plug into the motherboard, you can run both of these from the same plug. And I've done this on several machines actually with 0 issues whatsoever. However, because we are going to be using this motherboard, we have 2 separate plugs for Z. So what I'm actually going to do is I am going to use this splitter, but I'm not going to use one of these plugs, and I'm just going to run 2 separate wires to Z. It gives us a little bit more control, and then if we want to do like sensorless homing or something like along those lines later on, you can do that. So just so you know, if you're installing this on your Aquila or Ender 3, you can use this. It will work perfectly fine with a single Z plug. However, if you have an option like this or a different Creality board that uses dual Z, you can go ahead and use this as just a plug, and you don't have to use it as a splitter. Okay, let's keep going with the install. All right, guys, today we got a lot done. It might not seem like it, but the chassis brace is done, the feet are done. It looks really nice. I'm super happy with the way that it came out, both front and rear. I love the fact that it's all tied in together now, and now there isn't kind of like a random foot that also needs a place on the front end of the machine. It's all being held on by this extrusion, and it's all tied together. Just makes me feel better about the bottom of this chassis, makes it a lot more rigid. Then we went ahead and installed the Creality Dual Z, and as you saw, it was really simple and easy and straightforward. The one thing that I didn't do is obviously plug it into the motherboard, but essentially if this was a stock Ender or a stock Aquila, you would use that Y connector, plug it into both your Z motors, and plug that new connector into your motherboard and just unplug the old one. Pretty simple. If you were also doing a motherboard upgrade, then you can do it the way I did it. You will have two separate plugs for Z's, or you can still use the Y connector just to a single plug. It will work perfectly fine. Couple things to note about the kit. It does come with these braces that go on the top that hold the lead screws in place. They do have a floating bearing inside, but the floating bearing only moves in one direction and not all the way. I'm going to choose not to install these, and let me explain why. Essentially, if you have everything tied down on these really inexpensive lead screws, they tend to wobble to some degree. And in fact, if you undo everything and kind of hook up your motherboard and have the lead screw just spin, you will notice that the lead screws are not 100% straight. So what will happen if everything is tied down and together and tight on the lead screws is they will have some level of influence in your prints, and you might see more layers and actual layer lines in your print. The way you want these to work ideally is you want these wheels that are in this channel to be the only thing that's guiding your print perfectly straight, and then you want your lead screws to only lift your Z-axis up and down. That's what you want. You don't want them influencing any kind of movement left, right, forward, backward. So the way to do that is, one, potentially not have these. I know there's some debate on this, but I'd like to remove them off, and then also make sure that the pieces that actually screw into your lead screws, the things that actually move up and down, the actual things that screw onto your lead screws, take your Allen keys and make sure they're loose. You don't want them to be super tight. You actually kind of want them to be loose. You don't want them to just be dangling around, but you don't need them to be tight. And the reason for that is that tiny amount of play will allow the lead screws to just move things up and down, and then these wheels to do their job is to guide the entire gantry up and down nice and smooth. So that's worth noting there. The other thing that you are going to need to do with this type of system, because the screws are independent of each other, they're not connected with a belt of any kind, at least for now, what you'd want to do is, I like to take my large Allen key, I go down here on the bottom and place it down, and by hand I come back here and I move this side all the way up, and then I bring it down until it sits on the Allen key. Make sure the Allen key is sitting in its groove at a 90-degree angle. There you go. And as soon as it touches that, I move it away, and then I'm going to come down on this side. I'm going to do the same thing. I'm going to make sure that this rests right on top of it, right there. Let's check if the side's still straight. Perfect. So now we know that your Z-axis and your X-axis are perfectly straight, or as close as you're going to get to straight. It doesn't have to be absolutely flawless. That's the point of the leveling of the bed. You're essentially making sure that this is going to be leveled to your plate and not so much to the table. Essentially, that's why it's called tramming and not leveling, because you're not actually leveling the bed to the table. What you're doing is you're leveling the bed to your X-axis that goes from left and right of your printer. So Allen key, everyone gets one of these in one of these printers. Nice and easy way to make sure that they are as even as they're gonna get. And then what you would do is, I don't have my system hooked up obviously, but then you would just move it up, make sure you lock these steppers. As soon as you move them up and down, they kind of lock. And then you would be set to just do either your manual leveling or your mesh or your automatic bed leveling, and then you should be good to go. So a major upgrade that's definitely going to help pull and push weight around on this machine, and I'm definitely happy to see a dual Z-axis on this. All right, I want to thank all the Patreon members. Thank you guys for your support. Thank you everybody in the Discord that's in there chatting it up, helping other people troubleshoot their machines, sharing everyone's prints. It's really fun to go into the Discord and just hang out with like-minded people, so definitely check that out. Links for everything here you'll see down in the description below. As always, if you guys are ever interested in something that I'm featuring in a video or talking about in a video, always check the links down in the description. I always have a section that says in this video, just to try to be as helpful as possible. So some of the stuff you'll see down there. As far as this project goes, I still have a lot more to do, but I think the next time you'll see this is I'm going to work on the box that's going to contain the motherboard. Obviously, make sure everything is nice and powered and running, and that's what we're going to do in the next build video for this machine. Okay, I think that's all for me. And as always, I'll see you guys down in the comments. Later.